Welcome to the Driller Newscast. I'm your host, Brock Yordy, and here is the news impacting the drilling, water, geothermal, energy, and construction industry for the middle of February 2026. We've got a heavy-hitting lineup this week, from the environmental costs of the Winter Games to a massive shakeup at the Department of Energy. Let's jump right into it, but I think we got to get back to some old school Driller Newscast, safety first. Beginning of February, you should have had that OSHA 300A log posted. It's supposed to be posted from February 1st through April 30th. You are required to have your 2025 injury and illness summary posted in a visible area for your crew. Don't let paperwork skip turn into an easy fine. Out in the field, on the rig floor, we're battling freezes and thaws. And I want you to think about slips, trips, and falls, black ice on steel walkways, rig mats. We cannot lose good people to a bad fall, busted elbows, broken wrists, all of those bad knee situations. So let's be smart. Let's make sure that we're looking and thinking about those risks, slips, trips, and falls, and that maybe most of the day it wasn't slippery. And then as the day got to the end, started getting cold again, and we had those areas freeze, and suddenly we've gotten somebody hurt. So take a quick site assessment, understand where these are, and let's make sure our people are safe. All right, Winter Olympics. Who's watching the Winter Olympics, from curling to downhill skiing to the uniform gate that's going on? There's all kinds of wild things. What I want us to think about is the 2026 Winter Olympics in Milan and its impact, or its water bill. The organizers have been forced to create a staggering 2.4 million cubic meters of artificial snow. That has consumed nearly 1 million cubic meters of water from aquifers. Specifically, as of right now, they're at 948,000 cubic meters from their major alpine aquifers. And I want you to think about, we're about to transition that snow melt, or what had already snow melted, into what's recharging our rivers, our streams, and our aquifers. This is a big deal. As the rest of the world looks on, we're consuming a ton of resources for a big impact. And just the same as the Western United States, the mountain ranges there are having these big issues. So I know I just threw out a bunch of cubic meter stuff, and you're going, Brock, it's the United States. So all right, I'll break it down Barney style. That 1 million cubic meters is 811 acre feet. 811 acre feet. Acre foot of water is 326,000 gallons. We talk about this from Lake Mead to Lake Powell. That is roughly 264,172,000 gallons. Or if that's a hard visual for us, and we always like to put this in other crazy terms, we get to the Summer Olympics next. That's 380 Olympic swimming pools. And we're only partially way through the Olympics. Beyond that, the carbon footprint is just as heavy. While officials estimated 930,000 tons of CO2, independent reports so far suggest that once you factor in the high carbon footprint of travel surges and all the other embodied carbon that comes into it, it's going to be more likely 2.2 million tons. That means these games that we're celebrating are a massive strain on our resources, and it's just adding. There's some great reports out right now that say by 2030, more than a dozen Winter Olympic sites will be ineligible due to erratic weather and not enough snow. By 2050, they say it could be more than 36 locations. The Olympic Committee is dedicated to sustainable Winter Olympics, the same as the Summer Olympics. And they're looking right now at Switzerland, to its great public transportation, to its reasonable winter snowpack cycle. It's a big deal, and we cannot have something that's bringing the world together to compete and champion our Olympians be such a detriment to an area. All right, let's jump back stateside, back to New Mexico. Water data for New Mexico is considered same as data for gold. In Santa Fe, the New Mexico House has approved a budget bill that includes $22 million for aquifer mapping. It's a big win, but the Bureau of Geology and Mineral Resources, along with what we had seen with President Biden's study of groundwater mapping across the country, they really needed $28 million to close critical data gaps in groundwater, especially as we see data centers and geothermal projects come up in New Mexico. We have the Navajo Nation asking about their water and where their water rights are and how do we hold them, not to mention New Mexico and Texas is not part of the Colorado River Compact. 7.5 million acre feet goes to the northern basin and 7.5 million acre feet go to the lower basin. This is significant because Texas and New Mexico has not gotten the water that they've been allowed, the same as Mexico. And we've seen that as Texas sued New Mexico over wells too close to the Rio Grande and their citrus farmers won. So this is a big deal. At the same time, New Mexico is in the news with their House Bill 207, which would allow the discharge of treated fracking wastewater into state systems. We have to get water back into the watershed. We cannot be losing this water to rivers getting pumped back out into the ocean. And so as we have these discussions, what is wastewater? What is recycled water? And when we get into those facilities that are treating this properly, and it's 99% pure, we need to be able to put that water back in ASR wells. There's so much here. And so this is a pretty high stakes moment for the New Mexico groundwater and the industry in general. Okay, since we were talking fracking, let's jump over to oil and gas. In the oil and gas industry, the U.S. has hit its new gear. The Energy Information Administration confirms we are now producing nearly 1/4 of the world's oil, averaging a record-shattering 23.8 million barrels per day. Despite global volatility, the American oil and gas drillers remain the undisputed backbone of the global energy market. We are seeing transitions away from fossil fuels, and we have to understand how long is it sustainable as we watch our big oil and gas companies transition to new technologies, back to deep gas, back to deep hot rock geothermal. That leads us into our big news. Washington, D.C., the Department of Energy has officially wiped the Office of Energy Efficiency and Renewable Energy, the Office of the EERE, off the map. It is gone. I'm insanely disappointed by this move, but this is the move that signals a total realignment towards energy dominance, which is our priority right now. The Geothermal Technologies Office, which has funded major projects we're going to talk about, has been pulled out of the old renewable sector and folded into the newly created Office of Hydrocarbons and Geothermal Energy, the HGEO. By integrating geothermal with traditional fossil fuel oversight, the administration is treating geothermal as a major power source. It's the new era for the federal energy, and the drilling industry is now leading the charge. I need us to understand when we name something hydrocarbons, as we have looked from an environmental footprint, as hydrocarbons not being a desirable trait, fossil fuels, renewable energies, how we get to low carbon, all of these pieces. This is a bold move to call it the Office of Hydrocarbons, but that is the direction we are going. Now, as I transition into my next piece, I'm throwing this in. June 2027, Rosemont, Illinois, Ground to Grid Conference, hosted by BNP Media, the Driller. You need to be there. We're going to talk about how we take thermal energy resources from the ground to infrastructure to the grid, and how we lower peak loads, how we talk about equitable heating and cooling in the entire life cycle. So as we talk about thermal energy resources impacting our grid, the major win in the field of thermal energy networks came at the end of December, beginning of January in Framingham, Massachusetts. The nation's first utility-owned geothermal loop is officially moving to phase 2. This is huge. The Department of Energy's Geothermal Technology Office has awarded HEAT, the Home Energy Efficiency Team, and Eversource an $8.6 million grant to expand the network. This is a huge win to Zainab and Nikki and Andrew and Angie and the entire team for Eversource and the entire team for HEAT, because this project, which currently serves 140 customers across 37 buildings, the new fund is designed to double that capacity while showcasing the cost reduction that come with scaling efficiencies. I'm so excited for phase 2. This is a beautiful moment for us in thermal energy networks. So since we're in Framingham, Mass, let's head west to Colorado to showcase that east and west of the Mississippi is doing their job. And out west, the Colorado Office of Energy just awarded $7.3 million in tax credits for innovative networks. Key projects to watch include the town of Vail, which is installing a network to connect the Vail Public Library to Dobson Ice Arena. At Vail, they talked about taking their major snow melt system off of gas, transitioning to thermal energy resources. Is great. And we also have Colorado Springs District 11, which is installing a campus-wide system for Palmer High School. These projects are proving that geothermal can save taxpayers money while delivering reliable heating and cooling in high altitude and urban environments alike. Thermal energy resources, our holistic approach from power generation to geo-exchange, heating and cooling, and they're no longer inobtainable or too expensive. And I want to showcase this in this next piece. Thermal energy for power generation is not limited to west of the Mississippi, as we are seeing a larger adoption on the East Coast with geothermal energy anywhere, just as we saw with Sage Geosystems in our discussion with them that was in the Driller back in November. The new 13-state geothermal power accelerator is bridging the gap between the West and the Appalachians, with states like Pennsylvania and West Virginia joining the alliance. We are seeing a major push to repurpose old coal and oil infrastructure into modern geothermal assets. This alliance is focused on streamlining permits and mapping deep earth resources to provide that firm baseload power to the grid, which we desperately need. We need to be able to retire these coal plants. It is not sustainable. It is a clear signal the skills we use on the rig every day, despite if it's water well, geotechnical, environmental construction, to oil and gas drilling, to our horizontal and directional, they are the same skills that will power our next centuries and beyond. No matter which state you're in, drillers, you have the power to make our grid more sustainable through geothermal heating and cooling and through power generation. The goal here is a just transition, which is what the state energy offices in Pennsylvania and West Virginia are doing right now with geothermal solutions to repurpose coal mines and oil and gas wells. They're also utilizing all of their subsurface knowledge and experience on existing well bores to aim to prove that geothermal just isn't a Western resource. I want you to think about the opportunities here for workforce synergies as we see oil and gas opportunities transitioning to our geothermal heating and cooling, or oil and gas transitioning to deep hot rock geothermal, and how we see these workforce opportunities and as we see more money. All in short, everybody, this is where we're at. Geothermal, thermal energy resources is our winning racehorse. And we all need to be part of capturing that and harnessing it and writing it into the 22nd century and beyond. Now I want to jump into my discussion with Dan Surgison. He has now been promoted at Salas O'Brien. This is part two. Congratulations on your promotion, Dan. I hope you enjoy this second half of this discussion as much as I did.
Still waiting for the day where a GC or a CM treat, that geothermal bore before they put the piping in and stuff as like a cooling tower, right? Or a boiler. Their conventional stuff that normally would come in late in the project. They'd land that cooling tower on the building, but they would always plan for that day, right? Like to a T, right? The crane shows up here, it comes right off the flatbed. We'll drop it here at 6 a.m. before anyone could notice, type of thing. Like I need that same level of care for this, what's providing the same heating and cooling, except, in the geothermal form versus a cooling tower. So yeah, still waiting for that day. It's getting better. It's getting easier with the people, not just the drillers, but more so like the construction managers, the GCs. Like they have a lot of experience, for some of them, like decades, but this is still kind of a new thing to them. So that's fine. Like they don't need to pretend to know everything. I'm happy to help them and admit that I don't know everything either, but kind of disarming everybody in a project early, if possible, has really paid dividends for, where I am today, but also the success of like projects that I've worked on with a whole team of people.
It's wild because we in the geothermal industry, no different than the drilling industry in general, we have egos and we're in it so much that it's second nature to us. But when you look at geothermal acceptance across North America, we are a flea on an elephant's butt compared to the rest of the conventional heating and cooling.
We
And
are.
like we because we're in conferences with other geothermal people, we're all talking the same talk. But the reality is every time you turn on the news or you watch something, they say heat pumps, and the next thing you know, they're talking about air source. And we're all like, like it's just so funny. You're absolutely right from a GC standpoint. It's not conventional. It's not the most adopted yet.
Yes. Yeah. And it's getting there. It is getting there. And, air source is good, right? But I always fall back on that worst case scenario type of situation, especially in New York, right? I mean, a lot of what I do is in New York. It's all over the place, but living here my whole life, and I'm close to a lot of the work we do here. That's a lot of the reason I live here. Um, but like in New York, on the coldest day of the winter, you need heat in your building. You need hot water, and it's the worst conditions outside for your air source heat pump to work. I mean, I could get into numbers and percentages and COP and all that stuff, but literally, how are you going to get heat out of 13-degree air? I mean, it is possible, but it's not. And then your electric bill goes crazy
It's
because,
not efficient. It's
right,
possible.
yeah,
It's not efficient.
yeah. So yeah, I have that same reaction you just had to air source heat pumps, but we do like them. We include them in a lot of our hybrid systems for those preferential times where conditions are good to remove heat from your loop or add it back into the building or whatever it is you want to do. And I mean, that's part of the reason I love Salas O'Brien. I mean, I'm plugging the company here, but it's true. Like we do look at all the sources and sinks, right? I mean, whether it's a thermal energy network or even just a standalone residential tower, like we like to have multiple sources, right? It's almost like an insurance policy, right? And you could take from the geothermal pot under the right conditions, or you could turn on, that electric boiler or the air source heat pump or the closed cooling tower, whatever, when you need it. And we like to build that into the controls, monitor that stuff. So it's easy to understand for a building operator. Like that's another thing with these is we have to kind of train the building operator. We have to make sure the controls are in place and understandable so someone doesn't just put it up to 100 hertz and we come back in 30 years, or not 30 years, but into a few years, and we're like, wait, this is overheating or something like that. So yeah, there's I like hybrid systems, I guess is what I'm saying.
So that'll be my last question as we wrap up. the holistic or hybrid approach, we are now, as we look at geothermal, we're looking at thermal energy resources, right? So we're looking at boreholes, but we're also looking at how we use water, and we're looking at how we use waste heat and wastewater heat, and how is that changing your mindset from St. Patrick's Cathedral, you know, a decade ago to right now? We just things are moving fast, like I've
Yeah.
said before. But how do you approach that, or what's the thought process?
Yeah, so I mean, I think back to St. Pat's, and we had, titanium everything, titanium pumps, titanium motors, heat exchanger plates. I remember I was crawling next to the previous cardinals buried, in the crypt, trying to find out where to put piping. That felt like a real trial by fire, that project, but I learned so much on it. That project, it's 10 standing columns. The deepest one is like 2,200 feet or something. And that alone, I was like, wow, this is insane. We worked with another mechanical engineer on that job with the firm I was with. I learned a lot from them, and it is fully redundant. There is actually, if you needed to take the geothermal system offline, you can. Like they built that in. So that's, warm and fuzzies that you don't always get on every geothermal project. And now, I guess what, 10 years later, we I don't think we need that full redundancy, right? I mean, we could set up systems where you could, obviously still maintain the system and make sure it stays running, but while you're working on it, or if something happens, whether a weather event or someone strikes a pipe or something like that, like we try to maintain that flexibility so you're not screwed essentially. But you mentioned like wastewater, right? So the wastewater heat exchange, I thought it was made up, honestly, when I came to NYGO like 10 years ago. And I was like, can this actually work? Then I thought about it more and more over the years. And then when I started at Salis in May of 2023, it was thrown right in my lap. We were working on the Alafia projects in Brooklyn, where I think they have like almost probably 300 boreholes there now and 12 buildings, I think, over the course of 10 years, but they're moving really quickly, so it might only be over 6 years or something. But that has geo. It also has the wastewater heat exchange. It has, energy recovery ventilators. It has solar on the roof. And I'm not saying we designed all of that, but just having like bringing wastewater heat exchange into the mix and understanding it and modeling it correctly and programming and all that stuff. I've learned a lot about that. But the myth that it just, maybe not a myth, but my initial like, oh, we're going to use wastewater heat exchange to heat and cool our buildings. Like, no way. I just refuse to believe that. But seeing it initially, I saw it in DC, I think, Washington, for the first time a while ago. And then shortly after that, only a few years ago, it was on the table for options for this Alafia project. And now it's up and running and it's working. And I'm like, wow, I saw it go in. I helped the modeling before it went in. Now we're seeing it perform. It's mind blowing. It's like it's optimistic for me for the future. It makes me want to do my job better, and it forces me to kind of keep an open mind because I was pretty closed-minded about wastewater heat exchange in the first place. So yeah, it's nice to have like a renewable menu of sources and sinks to, identify in your designs early, and then do all the engineering number crunching to figure out, what is the best fit for this project. So yeah, it's really been fun, honestly. I mean, not all the time, but it's been really fun to just understand new technologies and actually see them go in, just from an idea or even like a brochure you get handed, 10 years prior, like see it go in, talk about it, talk to the utilities about it, the project owners, the operators, the other engineers so that are on the team, and then seeing it get put in and then seeing it perform. And honestly, not smelling it. When I've been around the wastewater heat exchange, I haven't smelled anything bad. So yeah, just one of those myths that has kind of proven to be true, and it's totally a viable option. And like you said, it's kind of all snowballing, right? It's the momentum is moving forward very quickly and only getting bigger. So, um, So yeah, that was one that just stuck in my head in my career was like converting to be a supporter. And not that I was against the wastewater heat exchange, but I was just like, no, how? No way. And then now I'm a full on believer in it. So
That is sound advice, and I'll wrap up right here. You've talked about internships and you've talked about working with drillers in the industry. If there was one thing you could say to the industry right now about you know getting a project you know to actually civil construction execution the fastest, what advice would you give to a developer or a GC or the driller? Like, what would you come back to say we can do this faster than we are?
um it's a hard question, but there's so many things that go into it. Like a lot of times, like our developer clients, they won't gain control of that site until the same day they're going to put start drilling or something like that. There's rarely time, right? I mean, time is money. Developers don't want to waste it. No one wants to waste it. But I mean, I guess I would say having a someone that's done it before, it being underground coordination. Sometimes I just ignore everything above grade. I try not to, but most of what I do is in the dirt or, on the first or second floor. Um, so coordinating that, right? Like it comes down to, and I mean, people will probably laugh at this on the engineering side, but like CAD and Revit, AutoCAD, it's usually used for outside the building, right? Surveys, cut and fill, all that stuff. And then you only use Revit. It's really good at 3D models when you're in the building. So it's always one of these questions on projects where they're like, oh, do you need CAD or Revit? And we're like, I mean, we like to say Revit, but usually we need both because I mean, obviously your wastewater goes through a sewer that starts in your building or an outfall in your building and it connects to a sewer. But I feel like we're doing something similar, but there's a lot more flow, a lot more pipes. It's integral to your building, heating and cooling, and everyone's comfort. So, long way of saying, coordinating the underground as quickly as possible to identify your conflicts and where it's risky and I mean, everyone knows this that listens probably, but making sure you still get your distances, not only for thermal breakthrough between two vertical bores or many of them, but also, tight enough that they could fit the rig there and, they could move it around. They could have their support vehicles. They could dig the trench. They could fit the pipes in the trench. Like all that. It sounds crazy, but maybe it's back to my putting your drawings on the street without consulting with drillers or builders. Like, you know, it's oftentimes you really have to think through like, okay, how big will it be? How much space do they need? Obviously we need to make sure we're not drilling through someone else's pipe or whatever. That's clear. But, you know, just having that early underground coordination, I guess, would be my most concise answer, but it goes so much deeper than that because of and no pun intended, but just because of the stakes, the specific stakes for that project, if it's on multiple sites or if, you don't get access for a long time and survey's not done yet, there's a train, there's a water tunnel running through it, there's a subway nearby, like all that kind of stuff. That we seem to get a lot of here in New York City and even across the river in Jersey. Jersey's getting a lot more work. Um, that's what we stress the most if it's a new project, new client. Like, okay, here's what we could do for you, but we need to understand the physical constraints. What are you putting in the ground, all that stuff, because we have a lot of heat to exchange with that ground before you put a building on top of it most of the time, assuming new builds. And then, existing is a whole nother category. We could spend hours on that the next time I see you.
Yeah, this has been so great, and I haven't heard many engineers like you. Some of the great gurus you have at your company, and that are some of the geothermal masters out there, like voice communication and collaboration. But really, to say it takes a team instead of we're going to lay this all out and you just drill. It's almost like the movie Wedding Crashers. Make me a bicycle clown.
Yes.
Just drill. Just drill.
Yeah.
No, it's okay to ask these questions. It's okay to have a constructive conversation that could save considerable amount of time, but money. And that seems to be our biggest issue with these projects is the risk and cost overrun. So I love what you're saying there.
Yeah, yeah. Shut up and drill. We try to not. We don't say that. So yeah, no, I hear what you're saying, and yeah, that's like you said, a lot of rock stars here at Sal O'Brien above me that I'm fortunate to work with them, but I've learned so much from them, and I'm trying to, distill everything they've learned over their careers and try to reflect that in our younger engineers and also our drawings and our specs, right? We want any driller in any state or country, whatever, to pick up Sal O'Brien's drawings and obviously read through them details, but also expect the same type of approach from project to project. So that's also like what I'm trying to put a lot of my effort into to make sure those conversations are being had, right? And those drawings and those specs are somewhat similar to other projects. I mean, it's always you could always improve, right? So we're always changing slightly, but I'm always open to hearing what drillers have to say, what CMs have to say, so that we could be better in our approaches while also, helping the industry, not slowing the job down, making sure it moves along safely and, efficiency and performance of the system is maintained. There's a lot of balances and trade-offs, but yeah, getting everyone kind of at the table early. I mean, I can't really stress that one enough.
Awesome. Thank you for all the knowledge you've shared today. This has been awesome. It's been a lot of fun. I think no, I know the industry listening to this, the drillers, and then if we can get some more GCs paying attention to what we're all trying to coordinate here and whatnot, there's some good things to gleam off so that we got a lot of scaling to do. New York is only one state of many that is racing to, harness these thermal energies.
Yeah. Yeah, I do. I've heard it. I'm sure you've heard it. If you could do it in New York, you could do it anywhere. I am sort of a believer in that only because God, it's hard to dig a hole in New York without calling five authorities having jurisdiction, right? So, it's kind of, it's forcing, it's like, I don't know, you want to become an athlete or whatever, professional athlete, you get the best trainer and you're going to expect to eat a lot of, you know, go through really hard times to get that. So I almost by no means am I a professional athlete, but it feels the same, right? Like there's no better place to be for me right now than New York and going through these processes. A lot of times, you've been through it probably where, I'm not exactly lobbying, but where I'm engaging with the DEC and the DEP and DOT, all these acronyms in New York City, to improve their processes. And they want the projects to happen too. So we're doing it in Jersey too, like kind of just talking to them about, hey, is this drawing up to code? And if not, is there a window for us to improve the code so that, once we prove we're not contaminating aquifers and we're grouting properly and all that kind of stuff. So I know every state's different, but, I feel like I'm pretty scarred from working in New York, but it's, the scar tissue has grown back stronger and it's making me better at this and hopefully will make it easier for others. I'm very against the younger people have to pay, they got to pay their dues and all that stuff. I'd rather make it easier on them and they could scale it, like you said, to get more of these things in the ground, right? Because that'll help all of us. So that's kind of where I'm at in all this.
That is perfect. Thanks again for your time today.
Yeah, thank you, Brock. This was great.
Thanks again, Dan. This industry is so amazing. And I want you to look right now at the great professionals that have been coming on the newscast and presenting across the country. And we have this amazing lineage of boomers to Gen X to millennial to Gen Z, all entering the industry and collaborating. We've gone from the halfway to 150-year-old gurus to the halfway to 70 gurus. And it's a beautiful place to be. And I think back to this coalition that is being put together right now for thermal energy. thermal energy resources, as we see states across the country collaborating, as we go back to that 13-state geothermal power accelerator, to the New England heat pump accelerator, all driven by the great people at the Department of Energy seeing the value of thermal energy resources. And yes, we talk a lot about heating and cooling, but this low temperature, small megawatt power generation that is coming out right now, this geothermal anywhere, is so much closer in synergies to what we've been doing in heating and cooling with closed loops. It's such a brilliant time. And as I think about this, we have coming up the Thermal Energy Network Symposium in Baltimore by Geothermal Rising. We have the New York Geo Brooklyn Conference. You need to get signed up. And my next guest will be from the New York Geo Conference. You'll see Dan there presenting along with so many other great individuals. And, it's just perfect. It's, in short, we are joining together from east to west and north and south to ensure that our grid evolves. And who gets to help that grid evolve? The drilling industry. And that it's going to be the key component to us slowing extreme weather and climate change and greenhouse gases, and what our grandchildren and our great-grandchildren and beyond get. This is a massive market expansion, and that is exactly why we need to be participating on all levels. Check out thedriller.com. So much great content. Check out The Driller's Life by Jim Beath. It's fantastic. Johnny's putting out great content. There's so much going on. And I need you to go to the Driller's website and check out the Ground to Grid conference that is coming in 2027. But before we get there, you have Geothermal Rising in Baltimore. You got New York Geo in Brooklyn. New York Geo is going to be an amazing event. The last Brooklyn event, last year's event in Rochester was phenomenal. And as we look at that, we can go into IGSPA near St. Louis, along with all the other great events that will happen this year. Take the time, participate. And hey, Waterwell Drillers, your groundwater association conferences that are happening, geothermal drillers are groundwater professionals too. Don't listen to any curmudgeon that thinks otherwise. We need to be working together. Be safe. Have a great week.